Good Lord, ride all the way.
A 10,
9,
8,
7,
6,
5,
4,
3,
2.
1.
Hello, I'm Paul Cox and I'd like to welcome you to a very special show here at Slooh, presented tonight alongside our partners at Astronomy Magazine. So, what have we got lined up for you tonight? Well, on Friday night, the ice giant Neptune reached opposition. We'll kind of explain exactly what that means over the next 30 minutes or so with the help of Astronomy Magazine's Strange Universe columnist and Slooh astronomer Bob Berman. Now then, we don't usually do this kind of mixing topics up for our shows, but we simply had to share this one with you tonight. Slooh member David Malik posted this image to the members clubhouse earlier today, and we just wanted to showcase what's possible with Slooh's telescopes. David used the Canary Eyes half-meter plane wave telescope, that's a 20-inch telescope, to create this stunning 4-panel mosaic of the Orion and Running Man nebulae. We just had to show that to you. Actually, you look at the original image and it just pops out. So members, make sure you check out the clubhouse to see that. It's absolutely gorgeous image. But anyway, let's get back to the subject of tonight's show, Neptune. Now, before we welcome Bob to the show, let's take a quick look at our live feed tonight from Slooh's flagship observatory at the Institute of Astrophysics of the Canary Islands. It's home to the world's largest optical telescope. Did you know that? And also Slooh's half-meter and 17-inch telescopes that members control every night. Now, what we're looking at here, this is our all-sky camera. So what a great shot that is. I haven't seen that tonight yet. So this is the shot that members use to check sky conditions. You can see we've got a little bit of a yellow haze there, and that's a bit of Saharan dust, but wow, look at that, the Milky Way stretching down with the constellation of Sagittarius and a bit of Scorpius down there in the right-hand corner. We got the square of Pegasus rising as well. Now, let's have a look at the constellation cam that we've got running tonight. This gives us a field of view of about 24 degrees across. It's looking pretty cool, I have to say. And basically Neptune is right bang smack in the middle of that. I've got a little chart that I'll show you a bit later on that. But let's take a quick look then at the half-meter telescope. Not the really best telescope to use for planetary observing, but it still gives us some pretty cracking shots actually of Neptune. And we'll get the studio maybe to zoom in on those a little bit later when we show you those live images, because we will see the moon of Triton, which is pretty good. We've also got the 17-inch telescope running tonight, so that's looking a pretty similar kind of view as well. So you should be able to pick out Neptune and Triton when those go to colour. We'll get the studio just to zoom in on those when we show those for the rest of the show. Don't forget, Slooh members, you can snap images from all of the feeds tonight in the StarShare camera on the live channel at slooh.com. Oh, there it comes. Oh, isn't that pretty? By the way, many thanks for the lovely comments that you sent all of us here at Slooh, saying how much you enjoyed our African Ring of Fire solar eclipse show that we aired a couple of days ago. Wow, that started at 2:45 a.m. here in Connecticut, Slooh's HQ. And we went for a full 5 hours. To say we were a little tired after that one is maybe an underestimate. Anyway, look, let's get back to tonight's subject. We have actually a trivia question for our viewers out there in internet land. Now, the orbit of Neptune's largest moon, Triton, does something very unique and peculiar for a moon in our solar system. If you think you know what it is, tweet us your ideas to @Slooh and we'll tell you the answer later in the show. And of course, if you have any questions tonight, just send them to @Slooh on Twitter or use the Slooh chat box if you're watching on the show, or if you're watching the show on our live channel at slooh.com. So, many of you may be wondering what an opposition is. Well, the clue is kind of in the name. That's not meant to sound patronizing, but it did, I'm sorry. Neptune, when Neptune is at opposition, it's positioned opposite the sun in our sky. So basically at sunset, the sun's behind you, Neptune is rising in the east off the other horizon. So the planet's therefore visible virtually all night long. And as I say, it rises as the sun sets and is setting in the west at sunrise. Now, opposition is, I love this constellation cam view. You know, we're going to be fixing these constellation cams on all of our telescopes to kind of give us that lovely contextual view of what the larger telescopes are looking at. But anyway, opposition is also when a planet's apparent size is at its largest, and it's the best time to observe any planet. But for such a distant object like Neptune, it doesn't make as much difference as, say, Mars does when that's at opposition. Now, although Neptune is still too faint to observe with the naked eye, even at opposition, you'll be able to spot it quite easily, actually, with a pair of binoculars. The planet is currently close to the bright magnitude, I think it's magnitude 3.7 or something like that. And it's that star that you're seeing right in the middle of this view. It's Hydor, it's Lambda Aquarii. So that's a great signpost to use if you're using binoculars. Actually, we've got a little chart that we were going to show you now, which is just going to show you in those constellation cams. So that's exactly the same size as that constellation cam image, and it will show you the exact position to be watching Neptune tonight. Now, I also marked on this chart, actually, the position of Neptune. Let's go back to the chart a sec, please. The position of Neptune during last year's opposition, it's only moved by around 2 degrees in a year. And that's because Neptune has this staggering 164.8 year orbit around the sun. Now, if you want to take your observing beyond binoculars, if you want to make out Neptune's tiny 2.4 arc-second disk, you'll need a telescope. Probably, we'll ask Bob for his view on this, but I always say a magnification of around 150 times or more. And certainly with an 8-inch telescope or 10-inch telescope or larger, you should be able to pick out quite easily Neptune's largest moon, Triton. Even though that's a really dim magnitude, about 13.5, something like that. But observe that over a period of nights, and Slooh members do this with the telescopes. Observe Triton over a period of nights, and you'll be able to discover the answer to that trivia question tonight. But, you know, why should we be so interested in Neptune? It's just a big blue ball of frozen stuff, isn't it? You know, it's the last planet in our solar system, pending planet 9, of course, and we haven't even sent a probe there. I mean, how unbelievable is that? One of the major planets in our solar system, and we haven't sent a probe there. Well, hopefully our special guest tonight, Bob Bowman, Astronomy Magazine columnist and Slooh astronomer, can help us answer those questions. Welcome to the show, Bob.
Well, thanks, Paul. Great to be here.
Well, Neptune is then the furthest planet in our solar system, and has been for 10 years since the poor little Pluto was kind of deplanetized. But how far away is Neptune, and how can we put that kind of into a human perspective?
Well, I like deplanetized. That I've not heard that expression before. That's
Good
great.
term,
So Pluto.
isn't it?
Yeah, Neptune's, we could say it's 2.7 billion miles away, or in terms of Earth-Sun distances called the astronomical unit, it lies 30 astronomical units away. It's so far away that light takes hours to get there. So far away that the solar wind, by the time it gets to Neptune's vicinity, has thinned out and spread apart so that it actually is a safer environment than astronauts would have around here, because it's, you know, you're escaping from a lot of, and it's far enough away that its disk, you just mentioned, its disk is so small, even though it's about 32,000 miles across, 4 times the size of Earth, it looks only the size that a tennis ball would look when it's 3.5 miles away. So it's a pretty darn small disk.
That puts it into human perspective, doesn't it? And if we just hop over actually to either the T1 or the T2, the half-meter telescope view, you were saying, Bob, it takes hours for the light to reach Earth. So there it is. There is Neptune there, and little Triton off to one side. So we're actually seeing it as it was, what, 4 hours ago or something like that, aren't we?
Yes, fortunately, it doesn't change too much, so we're pretty confident that it looks pretty much the way it does right now.
Actually, the fact that it doesn't change very much, and its rotation from our perspective, doesn't really change very much. It's a really good object for people who are doing lucky imaging. That's kind of the proper word for kind of webcam imaging, because you can actually take hours worth of video of Neptune and put that together through some processing and capture some good frames without the rotation kind of mucking that up. But Bob, I would like you to tell us, there was this extraordinary set of circumstances, wasn't there? Something incredibly unique about Neptune's discovery, unlike any other planet in the solar system. So what was all that about?
Well, quite right. It was the first planet discovered deliberately with the human mind, with our intellects, rather than accidentally, the way William Herschel had found Uranus in 1781. Now here, Uranus was moving in an odd way, so it was suggested in the 1820s, as early as then, that maybe there was another planet beyond it. And John Couch Adams in England, as early as 1845, started making calculated where it would be. Turned out he was off by 12 degrees. Nice. A year or two later, that was in 1843. In 1845, Urbain Le Verrier, famous French astronomer, made calculations, was convinced that there was a planet, calculated it to within 1 degree, and he, unlike Adams, he did something very smart. He kept trying to get people interested enough to point a telescope its way. And he wrote to the Berlin Observatory, where Johann Galle looked for it on the very day he got the letter from Le Verrier. Wow. On that very day. And on that day, September 23rd, 1846, he found it within 1 degree of where Le Verrier had predicted it. So now arose a furor. Who gets credit for it? Was it Galle, who actually saw the thing? Was it Le Verrier, who calculated within 1 degree? Was it John Couch Adams, who years earlier had calculated but was off by 12 degrees? And when I went to school, both were credited. We said that the discoverers were Adams and Le Verrier. But about 10 years ago, the official astronomical organization took away Adams' credit for it and said that no, Le Verrier was more accurate, and he kept hounding astronomers to look for it, and that counts for something too. And so credit is pretty much split between him now and the German Galle, who actually saw it first.
I mean, there were actually, it was quite a little political situation, I believe, at the time, between the Brits and elsewhere. I think it was the Astronomer Royal was George Airy, wasn't it, of Airy Disk notoriety.
The famous,
and
that's
but
right,
it was his fault.
George Airy, yes.
He didn't follow up. He ignored, he ignored this calculation and didn't go off to prove it with some observation. But Bob, it actually turned out, there's a fabulous image there. We'll get the studio to zoom in even more on some of these, because you can see it kind of looks a little bit odd. So there is that kind of bluish green disk. Looks very, very disk-like, doesn't it, Bob? Rather, through a telescope, rather than the surrounding stars. But that's why this next little bit is maybe quite surprising, because it turned out that Neptune had actually been observed many, many times before, over a course of several hundred years, potentially, even with Galileo potentially logging it. But do you think
Galileo
it was
in 1612 made notations, always when he was looking, he was obsessed with Jupiter. So whenever he would note where Jupiter's position was, once or twice he got Neptune in the same drawings. But unfortunately, one of those times Neptune was just beginning its retrograde motion, so it wasn't moving against the background stars, so he didn't recognize it.
But of course, one thing that I did wonder, and going into retrograde is when a planet's apparent motion kind of appears to stop in the sky. But we've got that little chart again, actually, Bob, where I marked up, where Neptune was at opposition last year, and it's only moved 2 degrees in the sky. I mean, that's the equivalent field of view as a constellation camp. So do you think that may have had something to do with it not being discovered and spotted as a moving planet earlier?
Oh, absolutely, Paul, because remember, Galileo was used to much faster moving objects. Jupiter takes 11.86 years. Saturn, the slowest moving, is 29.457 years, call it 29 and a half. This is 165 years, so it's barely moving against the background stars. And so when he would observe it night after night and was really looking at Jupiter in the same field of view and saw essentially no motion, he can't be blamed for blowing that one. But boy, wouldn't have that been great if he had discovered it so long before. We're talking about 2 centuries before Gala and Leverrier found it. That would have been amazing.
It would. I reckon this is a great project, actually, a great long-term project for Slooh members. They're always looking for good projects, and tracking some of these planets in these new constellation cameras over very long periods of time. And Bob, if we tracked most exterior planets, so Mars beyond, if we track them in the same field of view in a 24-degree field like this, we'd actually see them looping, wouldn't we, in the sky, or appearing to?
Quite so, and that's because the planets have an inclination to the flat plane of the solar system defined by the Earth-Sun orbit. For example, Neptune, if I remember right, has a 1.77 degree inclination to the plane of the ecliptic. Mercury's is 7 degrees, Venus is 3.4. And because of these little tilts, it means that as we're passing them and as we're moving, they don't just move forward and back as we pass them, as if we're overtaking a slower moving truck on the highway. It means we're above them or below them, and so we're seeing loop-de-loops and curlicues and all sorts of motions that actually drove the ancient observers berserk as they were trying to figure out what was really going on.
I mean, it was just so difficult for them to build a model, you know, which would take account of all these strange retrograde movements and things like this. I was doing some Mars imaging with the Slooh telescopes in the wide field scope, and I was just putting some of them together and comparing it. And I just happened to catch it accidentally, you know, during that retrograde period. And, you know, I strung some of those together and it did look good. But Bob, I mentioned earlier in the show that Neptune is popularly referred to as an ice giant, and even Astronomy Magazine uses that term sometimes on its cover from time to time. But I know in the past you've disputed that term, you know, on previous shows. Why do you think that that's not a particularly appropriate term for either Neptune or Uranus?
Well, I think it's okay. Part of it is just plain inertia or laziness, because when I went to school, there were 4 gas giants, and that was the 4 planets from Jupiter on outward. And it was only later that Uranus and Neptune started to be called ice giants. And the reason for that, and it's perfectly fine to do so, is that compared to those first 2 of the giant balls of mostly gas, hydrogen and helium, Uranus and Neptune have more what's called ices. They're really water, ammonia, methane, and we don't think of ammonia or methane as real ices. And in fact, as you go down deeper and deeper, it's true these things contain more of these substances, and planetary scientists do call them ices, but in truth, they're mostly in a liquid, warm, hot, or slushy form as you get lower and lower. So we shouldn't really think of ice as if we're going on a skiing vacation somewhere. Nonetheless, there's the term, and as long as we understand that the real distinction between Jupiter and Saturn is that these things have more water, methane, and ammonia. In fact, it's the methane that makes Uranus look so blue, because methane absorbs the sun's red light and reflects the green and the blue. Then we're fine. It's fine. It's a fine term.
Well, yeah, I mean, that's why I asked you, because I always think when you've given us that description before, you know, I think it's a good distinction to make, because calling it an ice giant, you know, it's very easy to think of it, or strap your skates on and you're going to be off. But actually, we're going to talk about whether or not there's any merit in human exploration of that system, and maybe Triton a little bit later on in the show. But thank you very much for now, Bob. We're going to see you a little bit later, and we'll talk about that. And we'll also give the answer to that trivia question we posed earlier in the show, the reason Triton's orbit is so unique among our solar system's moons. So we'll see you very soon, Bob. The answers to those kind of questions are fascinating, so do stay tuned. But before we get to that, I want to reach out to our viewers tonight from around the globe. I want to encourage you to join the expedition to explore the universe with us, which we do every day, kind of every night at Slooh, but now we've got the solar telescope as well. That was up today, which is pretty cool. Our members, they're not passengers, but they rather kind of sign up as a working crew to take control of those robotic telescopes that we're watching tonight in the Canary Islands in Chile. Oh, by the way, Chile's going to be open a little bit later. Saw some great mission schedule for that. But you can use those robotic telescopes to share the most interesting places in space with everyone else in the community. And we kind of say Slooh's like social exploration. And together we've already visited over 50,000 different places in the sky and captured over 5 million photos. I was going through one of our archives the other day. Oh, wow. It's fascinating actually to watch the progression of Slooh's telescopes over the years. But anyway, working as a team, it makes it really easy to learn from each other and share our diverse perspectives. It's fueled kind of in equal part by science and imagination and the human spirit to just search and wonder at all of this stuff that we're seeing now. Yeah, who knows? We may be alone in the universe, but you will never, ever be alone at Slooh. I also wanted to share the secret's kind of out, but it's been a year in the making. There is a new Slooh coming very soon. I was working on that today and last night. It's smarter, it's more powerful than ever, but I think easier to use. So if you're a newbie to astronomy, you'll appreciate that, but you've still got all of that lovely complexity. So if you're an advanced astronomer who's an Astronomy Magazine reader, you'll still have access to all the fits and all the scientific stuff as well. We're really excited to show you that when it's ready. So you really all are welcome aboard Slooh's expedition into outer space, which is free to try. So do join our adventure into the great unknown, please. It is such good fun. Now, don't go anywhere because we are going to be right back with Bob Berman after this quick commercial break. Welcome back to the opposition of Neptune. Neptune at opposition. Actually, we'll ask Bob that when he comes back. I often wonder, if there's a correct way of saying it. I tend to say a planet is at opposition. But anyway, welcome back to the opposition of Neptune here at Slooh in association with our partners at Astronomy Magazine. Now, at the start of the show, I asked what it was that made Neptune's moon Triton, that we can see just to the left of the planet in this image. So the kind of blue bright object is Neptune itself, and just off to the left you can see Triton. It's a bit close to the planet now. It can vary quite a bit. It's kind of merging in there. We've also got a bit of wind as well. A half-meter telescope, an enormous telescope like that, isn't the best kind of telescope to view bright planets on, which is why we lose a little bit of a colour. But we've got a new planetary telescope coming online later this year, so that's going to be pretty cool. But anyway, we asked you that question. What makes Neptune's moon Triton so unique in our solar system's catalogue of moons? Goodness knows how many there are now. So keep those answers coming in to our live chat on the live channel page at slooh.com, or you can do that via Twitter at Slooh, and we'll reveal the answer a little bit later. And you can also ask questions for Bob Berman if you've got any questions about Neptune and Triton. And on that note, let's welcome back our special guest tonight, Slooh astronomer and the author of Astronomy Magazine's most read column, Strange Universe. Yes, it's Bob Berman. Bob, it is the most read column, isn't it? You had some kind of survey information, and it is, without telling a lie, it is the first page I turn to when I read Astronomy Magazine, and I even did that before I knew you.
Bless your two-chambered heart, Paul. I really appreciate that. That's very kind.
But it is.
Actually, you probably have a four-chambered heart, come to think of it.
Okay. But you did have some data on it, didn't you? And it was voted, I think, one of the most popular, if not the most popular column in Astronomy Magazine.
Yeah, that's right. The editor, the publishers do those surveys and things. I have nothing to do with them, but that's what they tell me.
They do indeed. Now, Bob, what do you make of this image? I was just explaining there that Triton is actually quite close. It does vary quite a lot, doesn't it, in how close it looks to be to the planet. We won't give a spoiler away, but is that right? It does vary quite a bit, doesn't it?
It does. It's bright. That's why it was discovered that same year, 1846. It was discovered less than 2 weeks after Neptune was found. So that's pretty darn good to see a moon that far away, 30 astronomical units away. But it has to be big. One of the big ones. It's really one of the major moons. When you think of what are the moons that are about the size of our own, because we've got a big one at 2,160 miles across. There's not a lot, there are the 4 Galilean satellites. There's Titan going around Saturn, and there's Triton. That's it.
Yeah. So, and this kind of takes us nicely actually onto this next subject. The only exploration we've ever done of Neptune and its system was nearly 30 years ago when Voyager 2 sent back some of these pictures, while it was whizzing past on its journey through the solar system. Why haven't we ever sent a spacecraft mission to orbit Neptune to study it further? Do we think it's boring? And do you agree that with the fact that we haven't done so?
Well, of course, it's fascinating. We were all looking forward to that flyby on August 24th, 1989. Some say August 25th, depends on the time zone you were in. Right. That almost didn't happen because you'll remember that the Voyager spacecraft were primarily designed to look at Jupiter and Saturn, and only Voyager 2 went beyond as almost an afterthought. Yes, we'll visit Uranus in 1986, January of that year, and then Neptune, but it was almost thought to be expendable. So we're lucky to even have these. Should we go back? Of course. They're expensive, these missions. And, you could say, well, it's a ball of gas, at least on the outside. And how much money do we want to spend on it? But, it's huge. It's the 3rd most massive planet, 17 times the mass of Earth. Well, of course, we should have a closer look. And look at those great storms. And it's got the fastest winds in the solar system. Winds 1,300 miles an hour. Are you kidding me?
So
tornadoes
faster than
don't
Jupiter.
Even
faster than Jupiter, Bob.
I'm sorry?
Did you hear that? It's faster than Jupiter's storms and winds, is it?
Oh yes. It has them all beat. I mean, Saturn has tremendous winds too, westerlies. But here we've got winds from both directions, depending on the latitude that you're in. And you got a strange, even windy rotation of the whole planet. Generally, the whole thing spins, the equator goes around in about 16 days, matching the magnetic field of the planet, so it turns with the planet. But as you get further north, you get a faster rotation, 12-hour rotation. They have a 16-hour rotation, and that's sort of the reverse of what we see elsewhere, where Jupiter, for example, has a faster spin at the equator, slower at the poles. So this is it's an oddball planet, no question about it.
One thing that struck me with the New Horizons, when it arrived at Pluto, all of our preconceptions of Pluto was that it was, a boring little rocky ball way out there. We didn't expect any geological activity. This seems to be the common thing that we come across when we explore our solar system. We always get it wrong, don't we? So if we did send a mission out there, is there any merit in sending a manned mission to Triton? Do you think we might find stuff out there that we have no concept or guess about at the moment, Bob?
Well, of course. First of all, it looks like a cantaloupe. It's the most cantaloupe-looking moon. It's the coldest place in the solar system. It was measured by Voyager 2. There is no place colder. So, but before we talk about manned missions there, we've got a long way to go. We haven't even gotten to Mars yet. And then we've got some of the moons, especially Ganymede of Jupiter, that's outside Jupiter's fearsome, lethal magnetosphere. So we could safely go to at least Callisto. That's well outside the magnetosphere. That's the safest place. And then Saturn has its own moon system, and then Uranus has some fascinating moons like Miranda, in particular, where we'd want to do geology. So when we're talking about Neptune at 30 AUs, boy, I mean that's the distant reaches. From there, the sun is 900 times fainter than it is from here. That's far away.
Wow, Bob. Hey, we've got a question come in from Steffi on Twitter. Does the distance of Neptune greatly vary throughout its orbit? So is it a fairly circular orbit, or is it quite an elliptical orbit?
It's got an eccentricity of 0.05, very close to that. In fact, all four of the giant gas balls, or ice balls in this case, are close to that eccentricity. So they are rounder than Mercury, whose eccentricity is 0.2, but not nearly as perfectly round as, let's say, Venus, whose eccentricity is 0.007. Eccentricities, just to remind listeners who may not know this, are always some number between 1 and exactly 0. So one would be not an orbit that's so stretched out, so elongated that you wouldn't even call it an ellipse anymore. And 0 is perfect round. So once you get to really round orbits, like the 4 Jovian satellites, all have orbits of 0.000 something. Those are dead on circular orbits.
Okay, so this means that its apparent size, as far as we're concerned, even at opposition, when we're going from one side of the sun to another, doesn't really change a great deal, does it? Certainly not, visually through a telescope. That's
correct.
Now, I have been asked, we were talking about this the other day, and many of us know that Saturn and Uranus have rings, but a lot of people don't know that while Voyager 2 was flying past Neptune, the images it beamed back revealed that Neptune 2 has rings. So what do we know about those, Bob? And is it possible to, as an amateur, to observe this? Isn't there something you can do if they transit in front of a star?
Not really, no. These are very, very skimpy things. We call them rings, but they're more like fragments and more like arcs. They look like complete rings here, but they're very, very flimsy and skimpy. We hate to give them the full credit. It's like here in New York State, there's a place called Leechmere State Park, and it's advertised as the Grand Canyon of the East. Well, honestly speaking, it's not the Grand Canyon.
Okay.
And similarly, those magnificent rings of Saturn are really not duplicated elsewhere in the solar system. The others are just little tiny flimsy fragments. And no amateur telescope can hope to see it.
Okay, so thank you for that. Now, Bob, Neptune, named after the Roman god of the sea. We were hoping actually to have one of those mythology segments from Tricia tonight, but we ran out of time for that. But Neptune, god of the sea, and its moon Triton was named after his kind of mighty three-pointed spear-like weapon. Can you tell viewers the answer to our trivia question from earlier? What makes Triton's orbit so unique among the other moons in our solar system?
It is the only major moon that orbits backwards instead of going in the normal counterclockwise direction, which is all major moons as seen from north of the solar system look like they're counterclockwise. This one is the wrong way. It's a 5.88 day orbit, almost 6 days to go around once. Here's what's strange. Okay, if it's a retrograde orbit, it has to be captured because everything in the solar system essentially is one way. So it must have been a captured object, probably from the Kuiper Belt. But if it's captured, how the heck does it end up with one of the most perfectly circular orbits in the entire solar system?
Ooh, hadn't thought of that.
If I remember its orbital eccentricity, it's 0.00016. It's indistinguishable from perfect circles. So a little odd that it should end up with that kind of a perfect orbit being a captured object. But it does.
I hadn't thought about that one, Bob, but that makes it even stranger. certainly in our universe. Now, Mark Majensky on Facebook and Slooh member Stefan Aman both answered the trivia question correctly, and at the exact same time. Unfortunately, there weren't any prizes anyway, except the glory of being called out on a Slooh and Astronomy Magazine show. So, Bob, thank you so much for joining us tonight. It was a great show and filling us in on everything we need to know about that distant, cold, unexplored world, Neptune. So thank you very much, Bob.
A pleasure, Paul. Thank you.
That was Bob Bowman, Slooh astronomer and Astronomy Magazine's Strange Universe columnist. Now, I said it at the top of the show, and it's true. In fact, I just got my copy, my September copy of Astronomy Mag. I'm a bit behind today, and I know, like me, many of you Astronomy Magazine subscribers out there turn to that page first when the copy of the Astronomy Mag plops onto the doormat, and you can still pick up actually that September issue. And if you're a student or teacher returning to school kind of around now, this month's Strange Universe column is for you, but be warned, it can be quite testing. Okay, you have been warned. Well, that just about wraps up looking at this live image from the half-meter telescope there. We got some great missions scheduled. Members have got some great missions scheduled for later on. The Chile telescope, I think, is just coming online as well now. But that kind of wraps up the opposition of Neptune tonight. I didn't ask Bob that question, did I? Optune of Neptune, Neptune at opposition. Tell us, tweet to us on that one. We've had some fascinating insights about Big Blue, the ice giant Neptune. We hope you enjoyed the show. And if you're not already a Slooh member, why not? And why not join tonight? It's great fun. After all, kind of where else do you get the opportunity to control huge telescopes at one of the world's best observatory sites and to get to share your journey with such a great community. Now, before we go, I want to remind you of an upcoming event here at Slooh. I am really looking forward to this one, not least because we've got Bob joining us for this as well, but on September 16th, it's the Harvest Moon Eclipse. Isn't it great when these things come together, several events join together, and we're teaming up as normal for all of our full moon shows with our friends at the Old Farmer's Almanac to bring you all the folklore of the harvest moon and finding out what made lunar eclipses interesting throughout history. Bob will be joining us for that show because if you didn't know, he's also the astronomy editor of the Old Farmer's Almanac. So Bob often has two hats on. I'd like to see his hat collection. It'd be quite fun, actually. He's got some pretty good hats, actually. I know that. So that's about it for now. Thank you very much for joining us to explore that strange, distant planet Neptune tonight. I'm Paul Cox. This has been a Slooh astronomical production in association with our partners over at Astronomy Magazine. We will see you very, very soon. Bye for now.